All right, so today we're going to talk about geometric series and sequences. So yesterday we were doing arithmetic sequence and series, and so now we're going to do something called geometric. So with arithmetic, remember when we went from one term to the next, we would add by a common difference, or we would subtract. So our common difference then would be a negative number. This is similar, except that if you look at the first series here, the 2, 6, 18, blah, 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 1, you see that we're not adding here. I mean, the numbers are getting larger, but we are not adding. In this case, what we're actually doing is we are multiplying. And since we're multiplying, it's similar to a D, but we call it an R for common ratio. And our common ratio would be 3. And if you notice, each time going from one term to the next, to the next, to the next, we're multiplying by 3. So we say that our R is 3. Now you can look on your paper packet that you were given, and you can see what the formulas are for the explicit geometric and the sum of a geometric. And we will go through those in a minute. I want to look at the next one here. Now this one's a little bit different. Hopefully you do see that the numbers are getting smaller as we move from left to right. So when that happens, usually what the situation is then is our R would be a fraction. Now some people tend to have trouble with these, so I'm going to give you a way to handle that. For this one, I think it's pretty straightforward. You can see that you're dividing by 3 each time, and you should remember that dividing by 3 is the same thing as multiplying by 1/3, so your common ratio would be 1/3. Now, if you go to your packet and you look at question number 2, that one is a little bit different. I would like to look at that one. If we look at that, we see that you have 243, then the next term is negative 81, and then the next term is 27, and then it's asking you to give the next, what do they want, 3 terms. All right, now you can see that the numbers again are getting smaller. Notice also that the sign is alternating. We're going positive, then negative, then positive. When that happens, not a big deal. All you're going to do is just say, oh, wait a minute. Since the signs are alternating, that must mean that I'm multiplying by a negative number. So your R is just going to be negative. So that's not a big deal. Okay, so let's just look at, and I just wanted to get a little bit of room here. Let's look at the way we can figure out what the R is. If we're going from the first term to the second term like this, what I tend to do is I tend to take negative 81 and I divide that by 243. And then you can either use your calculator or your brain, and you will see that that is negative 1/3. Okay, so your R here would be negative 1/3. So then each number after, let's say 27, for example, you're going to multiply that by negative 1/3. Okay, and then you would end up getting negative 9, and then you would multiply that one by negative 1/3, and so on and so on. And that's how you would handle that one. Let's look at the next question. So let's look at number 3 in your packet. And number 3 states to find the formula for the nth term of the geometric sequence. Okay, now remember the nth term, when they ask for that, really what they're asking for is the explicit formula. So you're going to do a sub n equals a sub 1 times r to the n minus 1 power. That's your explicit formula for the geometric series. So all you're going to do is, and remember when we do explicit formulas, we leave anything with an n in it. And we do have that our a sub 1 is 3, so we write 3, and they gave us our r, and our r is 2, and then we say to the n minus 1 power. So that is the formula for the nth term. Okay, so nothing fancy with that one. I'd also like to take a look at number 5 in that packet. If you look down toward the bottom, it's asking for the sum. So if you look at your sum formula, you have S equals a sub 1 times 1 minus r to the n, and that's over 1 minus r. Okay, now we're just going to plug in the numbers, nothing crazy here. So we're going to plug in, let's see, they gave us that our a sub 1 is 1. You can write it or not because it's really 1 times anything, obviously, it's just that anything. and then we're going to write 1 minus. Now this is where we need to be a little careful. Our r is a -2, so let's put that in parentheses. And we're going to be raising that to the 20th power. Close the parentheses. And we're going to be dividing this whole thing by 1 minus -2. All right. The reason why I want to do this is you have to be really super careful in your calculator when you're doing this. What I want you to notice first is if we were doing PEMDAS, the first thing that we should be looking at is right here, and that's -2 to the 20th power. When you put that in your calculator, please make sure that you have an open parentheses, then put the -2 in, close your parentheses, and then to the 20th power. Okay, you're going to get something funky looking. Don't worry about it. Once you get that answer, then you're going to do 1 minus second answer in your calculator, okay? I'll repeat that again. So 1 minus second answer in your calculator. Now, when you do that, you should get -104,8575. Okay? If you don't, go back and repeat what I just said and try it again. And then obviously in the denominator, 1 minus -2 is a +3. And then when you work that out, you're going to get -349,525. Okay? So just be really careful when you're putting this into your calculator. Again, I can't stress enough. Kids get this wrong just because they're very careless right here in this spot right there. Okay, so just again, please make sure that you do PEMDAS. So you're going to do your exponent first. Get that, and then in this case, you're going to do 1 minus whatever that answer is. Okay? All right, the next thing also that I just want to talk about is you will see that there's going to be some questions. Please read them carefully in your packet that say find the sum of the infinite geometric series. So when it says find the sum of the infinite geometric series, please make sure you use the sum formula. It's given to you. It's in your packet. A sub 1 over 1 minus r. This is for the infinite sum formula. Okay? And just go through and read it. It's very straightforward. And then also at the bottom of the page where it says infinite geometric series in your packet, look, it does talk about converging and diverging. Okay, and all converging and diverging is when you go ahead and you find your r, if your r is between a -1 and a 1, then you're going to have a series that converges. So if your r ended up being 2/3, you have a converging series. Now, if you ended up having an r that was 3/2, you would have a diverging series because your r is bigger than 1. Okay, even if this last one right here was a -3/2, it's less than -1, so it would be diverging. And all you're going to see is they're going to give you a series and they'll ask you, does it converge or diverge? So I wouldn't get too crazy with it. So what I'd like you to do now is go through the packet, work the best you can through the questions, and I will go through anything that you still have difficulty with tomorrow.